Looking at our 8.4 notes, we are going to be looking at angles of elevation and depression. So a little vocabulary to get us started. Angle of elevation is an angle formed by a horizontal line and a line of sight above the horizontal line. So you can see in the diagram here that this is my horizontal line. It's parallel with the ground, and my angle of elevation is going up from that horizontal line. An angle of depression is an angle formed by a horizontal line and a line of sight below the horizontal line. So again, here's my horizontal line. It is parallel with the ground, and my angle of depression is going down from that horizontal line. So when you kind of look at creating that angle of elevation or angle of depression, your line of sight looking straight ahead is creating that horizontal. If your angle is above that line, like you're looking up to the top of the tree, then you have an angle of elevation. If you are in, say, like a hot air balloon, you're looking straight out, that's creating your horizontal line. And then you are looking down at something on the ground, you are creating an angle of depression. We're going to use this idea of elevation and depression to create pictures. So they're word problems. And we're going to have to use SOHCAHTOA, our trig functions, to find missing lengths or missing degrees. So let's look at our example here. An air traffic controller at an airport sights a plane at an angle of elevation of 41 degrees. So it's giving us an angle of elevation there at 41. So let's underline that. The pilot reports that the plane's altitude is 4,000 feet. Let's underline that piece of information as well. There's a number included with it, just like there's a number included with our angle of elevation, so it's going to be important. What is the horizontal distance between the plane and the airport? Okay, so let's try to draw a picture, okay? So let's say, you can really kind of view my art skills. Here's our airplane, and we know that it has an altitude of 4,000 feet, so it's straight up 4,000 feet. The angle of elevation is 41 degrees. So that means that there's an air traffic controller somewhere. So here's my air traffic controller. And they are looking up at my airplane, which means this angle is going to be 41 degrees. This is my horizontal to create that upward angle of elevation. And I'm trying to find the distance between the plane and the airport where my air traffic controller is. So I'm trying to find X down here. So what I want to do is I want to label the sides of my triangle that I've now created so that I can set up my trig functions. So in reference to 41 degrees, this side is opposite, this side is adjacent, and there's the hypotenuse. So I have information on the opposite side and the adjacent side. So I'm looking at tangent of 41 equals 4,000 feet over X. And then I can go ahead and cross multiply, and then I can find my value of X. So I'm going to get that 4,000 feet equals X times tangent of 41. Divide by the tangent of 41, just like we practiced in 8.2 and 8.3. X is going to equal 4,000 divided by the tangent of 41. Make sure you close your parentheses. And we're going to get 46,001 feet. It does say round to the nearest foot, so no decimals. Okay, let's look at another example. All right, get some practice in looking at those word problems. A forest ranger in a 90-foot observation tower sees a fire. Okay, so here I am in a 90-foot observation tower. The angle of depression to the fire is 7 degrees. So my angle of depression, 7 degrees. What is the horizontal distance between the tower and the fire, round to the nearest foot? So let's start with my 90-foot observation tower. Okay. So here's my tower. You can, if you want, there's my person, there's my forest ranger. And this observation tower is 90 feet tall. So I know that information. It says the angle of depression to the fire is 7 degrees. So that means that my person here in the tower is looking straight out. Okay, there's my horizontal. And then from that line, that horizontal, they're looking down at the fire. Okay, so there's my fire. This angle here is 7 degrees. So here's my angle, here's my triangle. And if you're somebody that can see it, I'll try to help everybody else out. This triangle here in pink is the exact same triangle that I have here in blue. So that means that this angle here in the upper right corner is also 90 degrees. And this angle down here on the bottom is also 7 degrees. They're going to match each other, which means this height is 90. Okay. It doesn't matter if you set up the pink or the blue triangle. Okay. If you're using the blue triangle, okay, we're trying to find this measurement down here. So when you're using the blue triangle, you have to remember that your angle of depression, that 7 degrees that I wrote up top here, is not inside the blue triangle. You have to move that angle down here. Okay. So in reference to my blue degree 7 down here, this would be opposite, this would be adjacent, and this would be the hypotenuse. Okay. So using SOHCAHTOA, I have information on the opposite side and the adjacent side. So that means that I'm using tangent again. So I have tangent of 7 degrees is going to equal 90 over x. So once again, we're going to cross multiply. I have 90 equals x times the tangent of 7. Divide by the tangent of 7. X is going to equal, go to your calculator, 90 divided by tangent of 7. Make sure you close your parentheses. And we are rounding to the nearest foot. So 733 feet.